right, so it says you read the first 20 pages of a book in 25 minutes. This is the last question on 5.2 before we get to 5.4. And then it says you read 36 pages in 45 minutes. Is the number of pages proportional to your time? So just like the problem we did where we had to write down the ratios from the pool, we have to write the ratios down from our book reading. So how would I write this 20 pages in 25 minutes? How do I write that as a ratio? 20 over 25. Now, what I will do is instead of just writing it as a ratio, I'm going to write it as a rate, which a rate is just a ratio that has been labeled. So just to make sure I'm talking about the same thing on both ratios, that's pages and that's minutes. That way, when I write the next ratio down, I can make sure I put the numbers in the right spot. So since I put pages on top of this ratio, I should put pages on top of the next one. So 36 pages in 45 minutes. I'd like to know if that's the same. Not the same number of minutes, not the same number of pages, but am I reading at the same speed? Okay. So if we cross multiply, which is what a lot of you guys like to do yesterday, you would do 25 times 36. Could someone tell me what that is? You'll need your calculators again. Hopefully you have those out. Ella, what's 25 times 36? Get a calculator. Rayleigh, do you have a calculator over there? Getting one. Maddie, what'd you get? 900. Okay. And then Maddie Yentez, what do you get for 20 times 45? Ah, so are the reading rates the same?
Yes.
Yes, they are. They're proportional. Now, as much as I love cross products, and it is my favorite, it may not give me as much information as method 2 dividing does. So for example, if I would have divided, did anyone do the dividing on their homework yesterday? They just did the top divide by bottom each time? You did that? Okay. So Maddie, what is 20 divided by 25 then? 0.8. And so you're going to get 0.8 on both of them, obviously, because we already know the answer is that they're the same. But the 0.8 is actually, if you divide the labels, pages per minute. So the 0.8 gives us the unit rate. So if I said, well, okay, I'm reading at the same speed, but how fast is that speed? It's not 900. It's 0.8 pages per minute. So not quite a full page. If you were reading a full page every minute, then in 20, you could read 20 pages in 20 minutes. The fact that this takes us 25 minutes means we're not quite reading a full page. We're a little slower than that. Maybe they're small text. That definitely, will slow you down if it's small text. But it's 0.8 pages per minute, and it's the same speed. So the answer is yes, they're proportional, and there's multiple ways you can find your answer. But the dividing method does give you the unit rate, which we've talked about unit rates. That's pretty important. Okay, so we finished the notes. Did anyone have any homework questions from the 5.2? Rayleigh. I'll give you guys a chance to get your work papers out. Unless you're completely done with it with 100% and just waiting to turn it in on Monday, get your work paper out now so we can get some stuff done.
Number 23.
Number 23, I'll look at number 23.
I have multiple.
Okay. Now, remember, this is the homework that you must turn a work paper in to receive any points. It's not one of those where, hey guys, I'm asking you to turn in your work paper. I'm going to give you 5 points for the work. No, you only get points if you turn in the work paper. And there's work on it. I don't want a piece of paper that just says yes, no. And if you don't know what I mean by yes, no, if you look through here, other than a few multiple choice questions, most of them are just yes, no, 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 yes, no. So let's look at one of those yes, no's. Let's look at number 8, for example. And I'll get to your 23, but maybe 8's one of them too. I don't know. You can use any of the 3 methods to find your answer. Yeah, Maddie? On 5.2? Oh, well, then I won't do 23. Are you sure it was 23? You might be talking about 5.1. Okay, ask me during success time. Okay. For 5.2, look at number 8 here. I don't want just a yes or no. And I know that's tempting, just be like, just guess and check, but I'm not going to accept it. So what I need to do is I need to use one of the 3 methods. Does anyone want to reduce these fractions? No, no one does. Okay. How about we divide the fractions? Aiden, can you tell me what 2 divided by 5 is? Always top divided by bottom here. Don't do bottom divided by top. What's 2 divided by 5, Aiden? 24. Branson, what's 40 divided by 16? It better be 0.4. I'll be so mad at you. Does yours only give you fraction? Bring it up here. Parker, what's 40 divided by 16? It does give you a fraction. Okay, you have to press another button to get a fraction for. I can fix that for you. 2.5. Is that the same? No. So the answer is no. What do I write down on my work paper then? Well, I write down 0.4 and I write down 2.5 and I write the word no down. I'm not asking a whole lot. Now, if you just tried the reducing method, and I know that no one wanted to, 2/5 is already reduced. Is there any way that 40/16 is going to reduce to 2/5? No, 40/16 is improper. 2/5 is proper. A proper fraction and an improper fraction will never equal each other. So there's no chance for this one. How about using cross products? We know it's no, but just humor me here. What's 2 times 16? So I write 32 down. And what's 5 times 40? 200. Are those the same? Obviously no. So the answer is still no, right? So I got multiple different ways I could get my answer here and show my work. You gotta do at least one of the methods. You can't just say yes, no. We scroll down a little bit. It's more of the same. Then you get to problems like these. Now remember, for these problems, you cannot use cross products because there's 4 ratios. Cross products only works when there's 2 ratios. So what method did we use when there was 4 ratios? We divided them. And what number did we put on top of our division? The y. The y number always goes on top. The x number always goes on bottom. It's inverted because when you graph on the coordinate plane, it's the x that always goes first and then the y. So it's inverted when we divide them. So what is 7 divided by 1? 7. What is 8 divided by 2? Well, I guess I could stop there, can't I? Because it has to be the same, and they're not. So the answer here for number 13 is no. What about number 14? For the first ratio, what's the y number? 5. So 5 divided by 2. 2.5. 10 divided by 4. Is it 2.5? 15 divided by 6. I got a feeling I know what the last one's going to say. What's 20 divided by 8? It is 2.5. They all are the same thing. Is this proportional? Yes. So that one's probably the most work I have to write down. Unless you did the reducing method. Because 5/2 doesn't reduce. So if all the fractions equal 5/2, which they do, 10/4 is 5/2. 15/6 divided by 3, 5/2. 20/8 divided by 4, 5/2. They all equal the same thing. And then you get to problems like these. And don't let these freak you out. This is the same thing. It just didn't give you the fraction pre-written. So you write it yourself. Parker, when it says 12 players from 21 teams, how do I write that?
Well,
That's right. Yeah, I'm just writing the ratio as a fraction so that I can compare it. What's the other fraction going to say? Anybody? 15p, 24t. Okay, so it's the same problem that I was doing up here, except instead of them giving us the fraction, I have to write the fraction first, but I can still use cross products. For those of you like you, I mean, cross products is one of the methods you could use. What is 21 times 15? 315? Is it 315? I got a bunch of different answers. Or did I? It's just right. Okay. What about 12 times 24? $288. Are those the same?
I'm getting 2.
You're dividing?
I am?
Yeah, it's cross multiplying. Yeah, you want to times them. 12 times 24.
Okay.
Okay, and then 21 times 15. Is that right? 315 then? Okay, so the answer for this one would be no, they're not the same. And I do the same thing for 17 and 19 and 20. Now for number 21, this one is the same thing. How do I write 90 sit-ups in 2 minutes? 90 SU maybe, sit-ups? That's fine, that's fine. Over what? 2 minutes? Okay, and I want to see if that's the same as doing 135 sit-ups in 3 minutes. So it's the same thing, except instead of yes, no, they want you to determine yes, no, and then they want a little bit more information. Now, if you investigate the information they're wanting here, they're wanting to know if the answer is yes, how many sit-ups per minute is it? Okay, so sit-ups per minute, that should make you think of a unit rate. And what do you do when you're finding unit rates? Divide. So let's not use the cross product method here. Let's use method 2, which was the dividing method. What is 90 divided by 2? 45 sit-ups per minute is how you'd label it. And what's 135 divided by 3? Also 45. So I know they're proportional. So I know the answer is yes. And I additionally know that it's got to be the top answer. Not 35 sit-ups per minute, but 45. So the cross products will tell you the answer is yes, but the cross products won't tell you how fast you're doing them. Right? I'm doing 45 per minute. Okay. If you have other questions on this homework, you can come ask me. And we're actually just going to move on to our lesson for today, which is section 5.4. Go ahead and download 5.4 off of Google Classroom. Give you a second to do that. My video that I'm going to show you guys. If there's time for it today, I'll show you the video today. If not, I'll show you Monday. One of the problems we're going to look at in this video is over a train called the AVE. And the AVE is a high-speed train that goes between Madrid, Spain, to Barcelona in Spain. And so it's a high speed, like it goes very fast, 302 kilometers per hour. If you're wondering how fast that is in miles per hour, we'll do the conversion when we get to that problem. And I have a video of me sticking my head out the window. No, I wasn't sticking my head out the window. I recorded from the window just to see how fast it's going. All right, so yesterday's lesson was titled Proportions, and you were trying to determine whether 2 ratios were proportional. It was yes or no. Today, instead of me asking you if they are proportional, I'm going to tell you that all of today's ratios are proportional. You have to find the missing number that makes them proportional. Okay? You have to find the missing number that makes them proportional. There are 2 ways that you can do this. The first method is by using mental math. So for example, look at this first set of proportions here. I need to know what number for X would make this proportional. What would make them equal? So I could think of it as 24 is being divided by what to get to 8? 3. So you could say it's like being reduced by 3, right? Well, if I reduce 21 by 3, what's that going to make X equal to? 7. Well, that's easy. How did I do that? I used mental math. I figured out what they were reducing by. Once I figured out what they were reducing by, which is 3, I was able to solve the problem by reducing 21 by 3 to get 7. Okay, so the advantage, if you're making a pro and con list for the methods, we should have done that yesterday. If you're making a pro and con list, the pro is that mental math is quick. The con is that it's not always easy. And if it's not mental, you can't do it in your head, then what's the point of doing it in your head? And so here's what I mean by that. What are they reducing 9 by to go to 6? Yeah, exactly. They're reducing it by 1.5. You knew that though, right? Sure. So if I told you what they were reducing it by, that's easy enough. What's 6 divided by 1.5? What's 6 divided by 1.5? 4? Okay, so W is 4. Problem is, I had to tell you what they were dividing by. I'm not going to do that in tonight's homework. You do. I guess you could guess and check, right? What are they? Let's flip this one around because these on. So let me do multiplying. By the way, when you're solving proportions, did you ever add or subtract on yesterday's homework? No, you were either reducing by dividing, you were dividing to turn into a decimal by dividing, or you were cross multiplying. So you're always multiplying, dividing. So it's never adding or subtracting. So don't tell me that they added 3 to get to 5 because that's not going to work. What they multiplied 2 by was 2.5. And here's how I know that. 2 times 2 is 4, and 2 times 3 is 6. So if I'm looking for 5, it must be between 2 and 3, 2.5. 2 times 2.5 is 5. Now, knowing that, what's 4 times 2.5? 9? Is it 9? I don't think it's 9. It is 10. Nice job. Okay, so mental math is great when it works. It's not so great when you get a problem like these bottom two. So let me show you a method, because I don't like methods that don't always work. Let me show you something that always works. Oh, I think you're familiar with it. Cross products. So I copied and pasted the last 2 problems we just did that were hard to do in our head, but I wouldn't even want you to do it in your head. I copied and pasted them. I put them down here. I'm going to show you how I would do this. Okay, so you remember yesterday we said that when you cross multiply, if they were equal, they were proportional, right? Well, I'm telling you they are proportional because there's an equal sign right here. So I know that the cross products have to be the same. So I take W times 9 and I call that 9W. I know that that cross product has to be the equal to or the same as the other cross product. What's 6 times 6? 36. And that gives me this nice one-step equation. And all I have to do to solve for W is divide it by 9. What's 36 divided by 9? 4. And that's the exact same answer we got up here, but now you don't need my help. What's Z times 2? 2Z. What's 5 times 4? 20. Okay, to get Z by itself, divide by 2. What's 20 divided by 2? 10, which is the same answer we got up here, but without my help. So the cross product, we're making a pros cons list. Pro, easy. Con, it's too easy. You're right, there's no con. There's nothing wrong with it. Cross products will always work. There is no disadvantage to using cross products. The advantage is that it's easy and you don't need my help. You don't have to try to figure out what number they're multiplied. Like, no, that's hard. What's easy is when you just cross multiply and come up with this equation and then divide the equation by 2. That's really easy. So for those of you that used the reducing or the dividing method yesterday, perfectly fine for what you did yesterday. Not so much fine for what we're going to do today. So we're going to transition to the cross products property, which of course means you just cross multiply. Butterfly method, some teachers call it. All right. So let's look at the first example. 7 times A is 7A. 5 times 21 is 105. And to solve this equation that I've created from the 2 cross products and an equal sign between them, I have to just divide by 7. And 105 divided by 7 is 15. So 15 is the missing number. If it's 15 over 21, my answer reduces to 5/7, so proportional. So my answer is just the 15, by the way. Don't put 15 over 20, it's just 15. A equals 15. Oh, a good point. Since this is an equation, I still need a variable. I still need to write a equals. Don't just put 50, it's a equals 15. All right, example B. B times 10 is 10B. By the way, I like putting the variable on the left side. You don't have to do that, but that's why I'm mixing it up. That's why I did the 7A first, and then I did the B10 the first this time, because I like putting my variable on the left side. What's 8 times 7? 56. Okay, and then take 56 and divide it by 10. 5.6. If you were in my extension class yesterday, not yesterday, Wednesday, this is what we did. This was your iExcel that you did within the extension class. Oh, by the way, dividing by 10, you can actually do that in your head. You just take the decimal point and slide it one spot to the left. That's all you have to do, which we're going to do again right here. 10 times C is 10C. 12 times 15 is 180. So I know those two cross products are equal. And because I know they have to be equal, that's going to help me find C, because it's divided by 10. And so that means take the decimal point and slide it over one spot to the left. And that gives you what? 18. Yeah. Thomas, what's 12 times D? Awesome. And what's 5 times 6? And go ahead and divide by 12 and tell me what you get for D. 2.5. Example E. Rayleigh, what's E times 3? You haven't been paying attention, have you? Okay, let's put that off and do the homework later. Okay. E times 3.
Yeah.
Just squeeze them together. Yep. And then tell me what 9 times 17 is. Okay. And then to get E by itself, we just have to get rid of the 3. And you said it was being multiplied, so we're going to do divide. And what's 153 divided by 3? 51. Now, I wouldn't give you one like this in the homework tonight, would I? Probably. Most definitely. So let me show you how you do a problem like this. You can't use cross products, can you? Yeah. I wouldn't have lied to you. We're still going to use cross products. What's different about this is that when we cross multiply the 15 to the f plus 1, we have to make sure the 15 gets multiplied to both those terms. And so the way that I ensure that is I can write that f plus 1 in parentheses. Because what do you do with the 15 when it's in front of the parentheses? Yes, you multiply it to both. And so f times 15, so that's called distributing, right? What's f times 15? 15f. And what's 15 times 1? Okay. Now, if you want to just save that step and not have to write that down, then when you cross multiply that 15 with the f plus 1, you could just think 15 times f and then 15 times 1 and just write that down. Ultimately, that's what you're going to end up with. So that's one cross product. The other cross product is 40 times 6. That's easier to do. What's 40 times 6? 240. So instead of getting a one-step equation like all the other ones, this one, because it's f plus 1, gives me a two-step equation. And we've solved these before. What's my cousin Eddie term? The 15 in the middle, right? The one that doesn't have an f. And so I subtract 15 from both sides. What's 240 minus 15? It is 225. And then that gives me 15f is the only thing left on that side. Now I'm ready to divide by 15, and I ran out of room. So what do I get when I divide by 15? It is 15. Yep, f is 15. That's just a coincidence, by the way. A lot of 15s in this problem. Just a coincidence. So recap. If I have one where it's instead of just F, it's F plus a number or F minus a number, I'm going to distribute the number I'm multiplying to both of those to get 15F plus 15. 15 times F and then 15 times 1. You can use the parentheses if you want to. That's what you did last chapter when you had parentheses. You had to distribute, right? So that's why I wrote it that way. Yes. You got 16F. Okay, that is a coincidence. That is because it just so happens to be that there's a 15 here and a 15 there. Okay, so if I take 15 away, then that would be your 16F. Okay, that is a coincidence. If it was not a 1 right here and that was not a 15, that method would not work. So be careful with that. Make it a two-step equation because it's probably not going to be like that in your homework tonight. Okay, I'm glad you asked that though. Yeah, math is about patterns, but you can't make a prediction like that based off of just one problem. You have to see kind of it not work before you can realize, okay, it only works for that. And so that's just a coincidence based on this problem. Yeah. Okay. So the next part, if we're going to take it to the next level, is to be, well, I'm not going to give you the proportion. You're going to have to write it yourself. And we did this in the homework yesterday, where you had to write the proportion, write the fraction down yourself. That's what we're going to do here. It says a benefit concert with 3 performers lasts 8 hours. That, by the way, is a ratio. It has labels, so it's a rate. So I'm going to write 3P or PER for performers. 3 performers lasted 8 hours. Go ahead and write that down. That's a complete rate. 3 performers, 8 hours. Now, on yesterday's homework, they would have given you a complete other fraction, and you would have told me if those were the same. Well, instead of doing that today, I'm not going to give you a complete other fraction. I'm going to give you one value and one that's missing. You have to tell me what missing value would make it proportional. So when you read the next sentence, it says, at that rate, how many hours? So you have to tell me what the hours is going to be in 4 performers. Where should I put 4 performers at on this ratio? Top or bottom? Adian says the top. This is why I label my ratios, my rates. This whole thing, by the way, is called a proportion. So the reason I label my proportions is because I want to make sure I'm putting the numbers in the right spots. Do you think I'll get the same answer if I put the 4 on bottom? No, I will get something completely different. So make sure if you're doing performers on top again, and we're going to put our X hours on bottom here, or H hours, whatever you want to call it. Now I'm ready to cross multiply. So all I had to do is write down what the problem was saying, and then now I'm ready to multiply. What's 3 times X? 3X. What's 8 times 4? 32. And what's 32 divided by 3? 10.6 repeating. That's right. Yeah, that last digit's a 7, and that's because your calculator rounds that last digit, but it really is 0.6 repeating. And then it's a story problem. And so what did X stand for? Hours. Another advantage to labeling your proportion is that when you go back and you're like, what was I doing? You're finding hours, X hours. So 10.6 repeating hours. Now, unfortunately, big ideas will not let you write your answer as 10.6 repeating. It will not allow you to do repeating decimals. So there's 2 things, you need to write this down. There's 2 things you need to know about this problem, about any problem. The decimal 0.3 repeating is 1/3. If it was just 0.3, it'd be 3/10, but it's 0.3 repeating, so it's 1/3. And our decimal 0.6 repeating is double that. Not 2, that's 1/3 still. 2/3, exactly, 2/3. So 0.6 repeating is 2/3. If you can remember that, and we'll use that a lot this year. So this is going to come back up a lot. You'll see repeating decimal and you're like, Mr. Wright, I can't type the repeating decimal in. Yeah, you have to write it as a fraction. So what big ideas is what I'm going to want you to write is 10 2/3 hours. Now you think you're going to have one of those in your homework tonight? Probably. Why else would I put it in the notes, right? So when you get the repeating decimal, just go back and refer to this. Here's a pretty typical proportion. 5 movie tickets cost $36.25. How much do they cost? $36.25 for how many tickets? For 5 tickets. Okay, so there's a rate. Now, if you're wondering why I inverted that and put dollars on top, it's because we always put dollars on top when we're talking about rates. Dollars per ounce, dollars per can, dollars per pound, dollars per fluid ounce, whatever you're talking about. We always put dollars on top. So dollars per ticket. That makes more sense than tickets per dollar, if I'm being honest. And then, so with that ratio in mind, that means I have to put dollars on top and tickets on bottom of my second ratio. And which of those two values did they actually give me? Did they give me the second dollar amount or the second ticket amount? Tickets, and that has to go on bottom then to match up with the other tickets. So the question is probably, what are you paying for those 8 tickets? Yeah, it has to be. What is the cost of those 8 tickets? So I cross multiply. 5 times X is 5X. 36.25 times 8. 290. And then divide by 5. 58 tickets, dollars. Again, another advantage to labeling your proportion is that you go back with your X, it says a dollar sign next to it, and you know what your label needs to be. $58. Per ticket? Wow, no, not per ticket. For 8 tickets. Right? If I wanted to know what it costs per ticket, I would take this full size ratio they gave me, the one that has both terms, and I could just divide it and find the unit rate. What is 36.25 divided by 5? What's 36.25 divided by 5? Okay, does that sound a better price for a movie ticket? Okay. Hey, stop. $7.25 per ticket. Now, so there is another way you could do this. Instead of writing a proportion, you could divide to see how much each ticket costs. And how many are you going to buy? You already bought 5. You're going to buy 8 of them. So you just times that by 8, and I bet you get $58. Okay. Now, that's actually what you did in the homework yesterday for section 5.1. I say yesterday, whenever you did it. Do you remember we did this one yesterday in class? We found out what it costs for each square foot, and then we said we're going to buy 12 of these square feet, so we times by 12. Yeah, we could have actually set up a proportion and said it's $68 for 16 square feet. So how much will it cost? X dollars for 12 square feet. And that's another way we would have cross multiplied and got 51. Okay, we just didn't know how to set up a proportion yet when we were doing this homework for 5.1. Here's our question with the AVE. You're riding on the AVE, a high-speed train connecting Madrid to Barcelona in Spain. The distance traveled is proportional to the number of hours traveled. How many kilometers have you? Okay, so this is just got, so it looks like we only had 2 questions left, but they just kind of asked us several questions about these 2 questions. It says, how many kilometers have you traveled in 0 hours? Which axis is the hours axis? The X or the Y? The X, okay. So according to our line, at 0 hours, how many kilometers have we traveled? Well, that makes sense. The train hasn't moved yet, right? We haven't been on the train. Yeah, so 0 kilometers. You've traveled 0 kilometers, which is why the 0.00 exists. Now, what's funny is, you remember when we were finding unit rates, I told you the only point you couldn't use was because what information do we have from that? No information. That means the train hasn't left yet. We have no information because we can't divide by 0. We can't get an undefined answer. What we could do though is we could divide remember how we always do Y on top? We could do 200 divided by 1. What's that? 200, and that would be kilometers because that was the Y number per hour. So the train's traveling 200 kilometers per hour. I think that's the next question. It is. We did 200 kilometers. That was our Y value. Oops, KM. Divided by our X value, which was 1 hour. By the way, that's our unit rate because that's 1 hour. And that gave us 200 kilometers per hour. What if you would have used this point? Do you think you would have gotten 200 kilometers per hour? Does 800 divided by 4 give you 200 kilometers per hour? Yeah, it does. What if you would have used this point? Does 600 divided by 3 give you 200? Does 400 divided by 2 give you 200? You could use any point on the line, right? Except the one that doesn't give you any information. The origin gives us no information. We got time to answer. If the train keeps the same speed, 200 kilometers per hour, how long would it take it to travel 505 kilometers? So if it travels 200 km in 1 hour, that's our unit rate, right? How long, so that's the number of hours, would it take us to travel 505 kilometers? Where would I put 505 km at? On top or bottom? Top, with the other km. And I'll put X on bottom, X hours, because it says how long. And I cross multiply. What is 1 times 505? 505. And what is 200 times X? 200X. And I need to divide by 200. So what's 505 divided by 200? 2.525. Is that it? Okay. There's another 2. Okay, so we'll just put, and this was this hours or was this kilometers?
Hours.
It was hours because our X is up here with the, down here with the hours. So I put hours next to it. We'll finish this problem up on Monday and I'll show you my high-speed video of my train. Have a great day, guys. 5.1 is due in the tray by the end of the day and 5.2 is due Monday. And when's this one due? Tuesday before you leave for Thanksgiving break. Yep. Huh? Did he call down the whole class? He should have just said everybody but these students.